So let's go ahead and consider a function f of x is equal to the square root of x. Now, in this exercise, all we want to do is find the derivative of f of x by using the definition of a derivative. Now, from your calculus class, you know that the definition of a derivative says the following. It says f prime of x, the derivative, is equal to the limit of f of x plus delta x minus f of x, all divided by delta x as delta x approaches 0. So all we want to do is apply this definition to our function f of x. Now, from the introduction, we already know that f of x is equal to the square root of x. Now, the only other thing that we're missing is f of x plus delta x. Now, to get f of x plus delta x, all you're going to do is reference the original function, and wherever you see an x, you'll go ahead and replace it with x plus delta x. And so when you do that, we end up with the square root of x plus delta x. Now, once we have these two terms, we just plug back into the definition of a derivative and find the derivative. So we're going to have f prime of x is equal to the limit of f of x plus delta x, which is the square root of x plus delta x, minus f of x, which is just the square root of x, divided by delta x, and as delta x approaches 0. Alright, so if you can go ahead and get this far along, this is the calculus step. Everything after this is simplification through algebraic manipulation. Right? So we have to think of something, an algebraic operation, that we can do to this expression to simplify it even more, to evaluate the limit. In this case, we can go ahead and multiply both the numerator and denominator by the conjugate of the numerator. And so when we do this, it's going to look something like this. We're going to multiply this by the conjugate of numerator, which is the square root of x plus delta x plus the square root of x. And remember to do it in the denominator as well. The square root of x plus delta x plus the square root of x. All right? And so just like any expressions that involve fraction multiplication, we'll go ahead and multiply numerator with numerator and denominator with denominator. And so in this case, let's go ahead and multiply the numerators together. So we'll go ahead and multiply the square root of x plus delta x minus the square root of x times the square root of x plus delta x plus the square root of x. And so from here on out, it's just using simple FOIL techniques. All right, so we'll go ahead and multiply the square root of x plus delta x times itself. And so when you multiply them out, we get x plus delta x. All right. Next one, we're going to multiply the square root of x plus delta x times the square root of x. And so this is going to be plus the square root of x times the square root of x plus delta x. Next term, we're going to multiply minus the square root of x times the square root of x plus delta x. And so when we do that, we get minus square root of x times the square root of x plus delta x. And finally, we're going to multiply negative square root of x times the square root of x. And so when we do that, we're going to end up with minus x. And so notice that there's a few things that we can go ahead and combine around here. All right. If you look at the middle term, both of these expressions are the same, but one is opposite and the other is negative, and so they just cancel out. The other expression that we can combine is we have an x right here, and we have a minus x right here, And so again, they cancel out. And so in this entire expression, this whole thing simplifies to delta x. All right. And so we'll go ahead and plug it in after we multiply the denominator. Right. So let's go ahead and multiply the denominator. And so in our denominator, we're going to have delta x, and it's being multiplied by this root of x plus delta x plus this root of x. Now, for reasons that you'll go ahead and see in just a second, I'll just go ahead and leave this exactly as it is. I'm not going to combine anything. I'm just going to write it exactly like this. All right, so now that we've multiplied the numerator and the denominators, let's go ahead and plug these expressions back into the definition of a derivative. Right, so all we're doing is we're going to go ahead and bring this expression down right here. All right, so we're going to have the derivative of f of x is equal to the limit. Now, in our numerator, the entire thing simplified to delta x. And in the denominator, we have delta x times x plus delta x plus this root of x. Right? And the limit as delta x approaches 0. Now, what you can notice is that both the numerator and denominator have a delta x term in it. Right? So since it appears both in the numerator and denominator, you can just go ahead and cancel them out. And we get that the derivative of f of x is equal to the limit of 1 divided by x plus delta x, this root of that, plus this root of x. And the limit as delta x approaches 0. Right. So now that we've simplified it this far, then we can evaluate the limit. Right? We'll go ahead and plug in 0 for delta x and see what we get. And so when we do, we're going to get the derivative of f of x is equal to 1 divided by x plus delta x, which is approaching 0, plus delta x. All right. And so let's go ahead and simplify. The derivative of f of x is going to be equal to 1 divided by this root of x plus this root of x. And so when you combine two square root of x's together, we're going to get that the derivative of f of x is equal to 1 divided by 2 square root of x.